Oh man, I forgot to hit play. So I got 2 problems done and I looked up to see how much time I had left and no time was going by. So I'm sorry, these first 2 are going to be worked out. You already had this step. So what I explained to the air before I turned on the video was that 1/5, we use the power rule and all those 1/5 come down in front. 1/5 times log 2. Minus 1/5 times log x, minus 1/5 times log y, minus 1/5 times log z. And what the textbooks like to do, and probably Alex does this too, is they like to take that GCF out. Well, if they all have a 1/5 in front, can I take it out and write what's left? Log base 2 minus, not base 2, log of 2 minus log of x minus log of y minus log of z. So that's usually how they want your answer. So if they all have the same exponent, they all come down in front because of the power rule, and then we pull it out as a GCF. So 1/5, and then write what's left. So that would be the very last one on page 2 of 8.5. And sorry, I worked out this next one too before I realized the video was going, so I'll explain it as we go. So go ahead and write the top stuff down. I just transferred the properties over because we're going to be going backwards on these properties, and this is just an arrow coming down in front of the log. I know it's off the paper, but if I make it small, then it's going to get really small, so I'm trying to keep it here. So the power rule just says take that number and bring it down in front. And then I have the product rule, which says the log of a product turns into the sum of logs, log of a quotient turns into the difference of logs. So you're probably thinking, why do I need to write these? I just did 4 problems with them. Well, you did 4 problems where you were expanding. It's a lot different to take the properties and condense. So what you're going to be doing is going from this to this, where on the last page you went from this to this. So now we're going to be going backwards. Oh, they want us to write as a single logarithm. Well, I write the word log once. Addition makes me multiply my arguments. Oh, they want a single logarithm, so I write the word log once. Subtraction tells me to put these in the argument and divide. So I'm doing the properties backwards this time, so that's why I had those out. So you're going to start with this, and then your first step is going to be to put it back up there. So I also wrote this, condense the logarithms, because some textbooks will say write as a single logarithm. Some textbooks are going to say condense the logarithm. So depending on who the author of the textbooks is, they use different language, and I just want you to be exposed to both. Okay. So rewrite as a single logarithm, assume all variables are positive. So the first thing I do, I'm going to need another sheet of paper, aren't I? Should I put my little dog here? So the first thing I'm going to do is look at this and go, oh, okay, well, if the last thing I did on the last assignment was bring the logs down or bring the exponents down in front, well, because now I'm doing the opposite, I'm condensing. So on the last page, we went from 1 log to several logs. On this page, we're going from several logs to 1. So the first thing we do is what you did before. You took your power, put it in front. So now we're going to take all of our numbers in front and change them into powers. So this is what it should look like. I have the answer there. That's why I'm covering it up. Get to it in a second. So why am I doing that? Because we're doing the opposite of what you did on page 2. So on page 2, we brought all the powers down. Now, since we're condensing, we bring all the powers up. So that turns into log base 19, 17 to the 1/4, log base 19y squared. And then this one stays the same because it has no number in front. So log base 19x. Okay, and then you have to remember something I just told you on that last problem we did right before the video stopped. I told you if anything has a negative sign in front, that means it goes in the denominator. It's following the rule of negative exponents. Remember how when we had answers like this in chapter 4, and you had to keep your x in the numerator because it was positive, but you had to bring your y squared down to the denominator to make it positive. So it's the same thing. So anything that has a negative is going to have to go into the denominator of the fraction to make it positive. So same rule as exponents. Now we're just doing it with logs. So the next thing I have to do, though, is rewrite this as a radical, because remember how on the last one we wrote all radicals as fractional exponents? Well, now we're doing the opposite of that, so we have to put it back in its original form. So this is the 4th root of 17. So log base 19, 4th root of 17, these two stay the same. Now I can go to my answer. So my answer is going to come from writing a single log, because see what the directions say? Single logarithm. So I wrote log base 19 once. Anything that's positive, just like with this, anything that has a positive exponent stays in the numerator. Anything with a negative exponent goes down. Same with logs. Anything that's a positive log, its argument goes in the numerator. Anything with a negative log, its arguments get multiplied in the denominator. So it will be 4th root of 17 over x times y squared. And they both go down in the denominator because of the subtraction signs. And they get multiplied down there because the subtraction just says bring them down, and then they get multiplied. And I rearranged the order just so it would be in alphabetical order. So the positive log, its argument goes in the numerator. The negative logs, their arguments get multiplied in the denominator. So now that takes away those negatives. And this one's a little bit harder to learn just because you're going backwards. But what you're going to notice, the problems are a lot easier to do. So let's do one more together, and then we'll let you try one. You could shut off your video and try number 5. But you can see this stuff isn't something you just get good at. You have to practice. So doing 3 of them in your notes, you're not going to learn them well enough for the test. So make sure you practice these on your homework. So once again, I see rewrite as a single logarithm. So that means my final answer should have log base 5. And I see there's subtraction, so I know there's going to be division. So I can get my final answer ready. So I know it's going to be log base 5. I know there's going to be division because of that subtraction. And let's do the work down here. So just like on the last one, the first thing you do is bring all the powers back to their location. So that 3 goes back there, the 9 goes back there, the 1/2 goes back there. So it's going to look like log base 5 x cubed. So we did the power rule last when we were expanding. We do the power rule first when we're condensing, because we're doing just the opposite of what we did on the other page. So plus log base 5 y to the 9th and then minus log base 5 z to the 1/2. But the minute I see a fractional exponent, my brain should be going ding, 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 something to do there. Remember, that turns back into a radical. So one last step before we go to our answer. So this stays the same, doesn't have a fractional exponent. This stays the same, doesn't have a fractional exponent, but in chapter 6 we learned that this is the same thing as square root of z. So 2 is the index, that's why it's square root, 1 is z's power. So this is minus log base 5 square root z. And that's the same thing as z to the 1/2 because it's power over index 1 over 2. Now we can go up to our answer. So just as we did in the last problem, anything with positive logs stay in the numerator and get multiplied. So it's going to be x3, y9. And anything with a negative, remember negative exponents go down, well negative logs, their argument goes down. So in the denominator we have square root z. So see what I said? Very little work on these, but you have to know your properties inside out. So first do the power rule, power rule, power rule. And then we have whole number, but that fraction turns into a radical. Positive arguments get multiplied in the numerator. Negative, its argument goes down to the denominator, just like a negative exponent. And that is the answer you would type in, Alex, or write on a paper pencil test, which you'll probably have next semester. Not bad, huh? So now I'm going to recommend that you stop the video, do number 5 on your own, and then start it back up and you can check it with me. This is our last one before we move on to something else. Okay, so anytime it says single logarithm, step 1 is to do your exponents. So all my exponents need to go back into place. So this is going to be log base n 5 to the 1/4. And right away I'm thinking, oh, these all have fractional exponents. That means they're all going to turn into radicals on the next step. Plus log base n x to the 2/3 minus log base n z to the 5/4. So first we do the power rule. Any powers that are fractions get turned into radicals. And notice all the powers are fractions, so we're going to have 3 different radicals here. So this is going to be log base n. And remember, the numerator is 5's power, so it's 5 to the 1st. The denominator is the index, so it's the 4th root of 5 to the 1st, which is just the 4th root of 5, plus log base n. The index is always the denominator, so it's the cube root of x squared. So far, so good. So the denominator becomes the index, the numerator is the power. And then we have minus log base n. Index is 4, so 4th root of z to the 5th. But that, I know you're not even thinking that. I hope you are, but I doubt it. This can be simplified. Remember, 4 z's come out as a single z, and this is 5 z's. So these 4 are going to come out as a single z. And then we have a z still underneath. So let's go ahead and write our final answer. So I know there's going to be a fraction bar because that's subtraction. So the positive logs, their arguments get multiplied in the numerator. So 4th root 5 times the 3rd root of x squared the negative log, its argument goes in the denominator. So we said that's going to be z